Alright, F. First of all, this is a like base. The base E and the base C, so I can add like terms. When you multiply like bases, add the exponent. So that's a rule. When you multiply like bases, you can add the exponent. So first thing I'm going to do is simplify my left-hand side. So I'm going to have E. Now my base, I'm going to have a 3x minus a 2x is just a 1x. And then I have minus 7. So we used our properties just to simplify the left-hand side. Now, I can't do anything. These aren't like bases, so I'm going to take the natural log of both sides. So take the natural log, the natural log. Just like we've done before, we can use our power rule to bring that out front. So x minus 7, natural log of e, is equal to the natural log of 4e. Now we're going to apply some of our properties of natural logs. I want you to recall that the natural log of e is equal to 1. And even if you didn't know that, you could put that in your calculator, natural log of e to the first power, and it's going to equal 1. So when this just simplifies to just 1, I'm going to have x minus 7. Because natural log of e simplifies to 1. So it's like x minus 7 times 1 is just x minus 7. Now over here, remember when we used our rules and we said we could break multiplication with addition? So I'm going to say natural log of 4 plus the natural log of e. Because this is multiplication, I can rewrite it with addition. Now what is this value again? 1. So really, if I continue to have x minus 7 is equal to the natural log of 4 plus 1. And I want to get x by itself, so I'm going to add 7 to both sides. And that would give me x is equal, I can't move it up any further, so it would give me x equals natural log of 4 plus 8. 7 plus 1 is 8. So I continued up here. Natural log of 4 plus 8, that's your exact value. Your approximate value when you put that in the calculator is 9.386. This is your approximate value. So this required you to use a couple of properties before of our, when we rewrite multiplication using addition. And then natural log of e is equal to 1. Okay. And I just realized that I skipped this problem right here. So they're not like bases. So I'm going to take the natural log of both sides. Natural log of e to the x squared is equal to the natural log of 100. And we'll x squared natural log of e is equal to the natural log of 100. What does the natural log of e equal to? So we recall just a minute ago we said the natural log of e is equal to 1. So that would just give me x squared times 1. And then if we're solving for x, how do you undo a square? We take the square root of both sides. Remember, when you take the square root, you're going to get plus or minus. So you're going to get one time with the plus and one time with the minus. You would put that in the calculator. We would get x is equal to plus or minus 2.146. So this is the approximate value. And this is your exact value. Okay, the last ones we worked on, we were solving with exponential functions, equations with exponentials, and then now we're going to look at equations with logarithmic functions. And basically we were going to change it from logarithmic form to exponential form. And I hope this starts to be familiar to you. If there's not a known base showing, for a natural log, we know there is a known e there. And remember, we would say this raised to this equals this when we change it from logarithmic to exponential form. So we're going to do the same thing. We're going to say this raised to this power equals this. So I'm going to say e to the 7th is equal to 2x. And then we're trying to solve for x, so I'm just going to divide both sides by 2. So my exact answer would just be e to the 7th power divided by 2, which is approximately 548, approximately, when you plug that in your calculator. Okay, the next one, we're going to change this from logarithmic to exponential form, so it's going to be this raised to this equals this. So it's going to be 5 to the 3rd is equal to 8 minus 3x. 5 raised to this power equals this argument. So 5 cubed is 125. Is equal to 8 minus 3x, and our goal is to isolate the variable. So if we were solving to get x by itself, I'm going to get 117 is equal to negative 3x, and then we divide both sides by negative 3, and negative 39 is equal to x. So basically, when we have one logarithm on this side, we're going to change it from logarithmic to exponential form and then solve. I want you to look at C, and there's a log plus a log. I can't take this thing to exponential form until I have it 1 log is equal to this. So I'm going to use my properties and condense these. Because there's addition, I can rewrite using multiplication. So this actually gets to be rewritten. Log, there's a known base 10, so I'm going to put it, there's a known base 10. If it's not shown, there's a known base 10 of x times 2x plus 1 is equal to 1. So what I did is I combined these two logarithms using my properties. Since it's addition, I can rewrite the arguments using multiplication. Now I have it in 1 log is equal to some number, like I did up here, so I'm going to change to exponential form. Once you have it simplified and condensed, now we can say this raised to this equals this. So I'm going to say 10 to the 1st power is equal to x times 2x plus 1. Then we distribute. That's going to give us 2x squared plus x. Now I want to get that equal to 0, so I'm going to move 10. And that would give me 0 is equal to 2x squared plus x minus 10. And we want to try to factor that out. Now we can go off to the side and try to do bottoms up. What multiplies to give us 2 times negative 10, which is negative 20, adds to give us a positive 1. So 5 and a 4 needed to be a positive 1, so let's check that. When I multiply these two, do I get negative 20? Yes. When I add these two, do I get positive 1? Yes. So once you find your factors, you're going to put them over your first term, which is a 2x. And then you're going to reduce. This fraction does not reduce, so I'll write from the bottom up. That's going to be 2x plus 5. This one does reduce. I can divide by 2, so I'm going to get 1x minus 2. Okay, I'm going to set this one equal to 0 and solve, and then I'm going to set this factor equal to 0 and solve. And then we're just solving these for x. Divide both sides by 2. X is equal to negative 5 halves. I come over here and I add 2 to both sides, and x is equal to positive 2. Now we need to check our answers, which we didn't plug in before, so let's go back up here. For example, negative 39, if you plugged it in here, I would have, we need to test our argument. So I have 8 minus 3 times negative 39. So 8 minus, oh, well, plus 117. So this is going to be a positive number, which is, as long as this is a positive number, this answer gets the count. So let's look down here. When I take negative 5 halves and I plug it in place of this argument, I would get log of a negative 5 halves. That means I cannot have a negative argument. So this value does not get to be used. Well, when I check this 2, log of a 2, that's a positive number. It's okay. But I need to check it in the next one. If I plug the 2 in right here, 2 times 2 is 4, plus 1 is 5. Well, 5 is a positive number. So this answer gets to count because whenever I tested it in the original arguments, it gave me positive values. When I plug this in, even just in the first one, when it failed one, it automatically fails. So we want to check our values to make sure that we get positive.